what I thought I would do today is explain just a little bit about Swegon, what we do and what we've done lately. Share with you a few of our past house reference projects that we've accomplished through the years. And that should take us probably to the end. I think there's plenty of content there for that purpose. The only thing I need now is for my presentation to respond. Swegon, I'll go ahead and start while we're waiting for that exciting moment. There we go. That's me. I've been with Swegon for nearly 20 years. Since I joined Swegon, our business has grown dramatically. When I joined, we were about 200 million in global sales. Now we're over $1 billion. Since I joined, we actually purchased 3 factories in North America. So all sorts of exciting things happening here. I've also become the chair of the ASHRAE standard 227, where we are writing ASHRAE's version of Passive House. Been working on it for 5 years, and we should very soon have the official publication, public review out for the world to review and comment on. Okay. So Swegon's been involved with Passive House since about 2008, when Passive House Institute first came up with a certification program. We were one of the first to get our ERV certified in the Passive House program. It turned out to be a fairly simple project for us because we didn't have to modify our product. What we were doing already was suitable for Passive House certification, and that remains true today. What we would call a Passive House certified ERV isn't anything special. It's one of our standard off-the-shelf products, but it's applied in a way that makes it Passive House certified. And that's an important distinction to make, and it's one of the things we discuss as we go through projects with our customers. So 2008 is when we had our first Passive House certified project use one of our projects. It was this school that you see here. It happens to have been in Germany. 5 years later, we got some more Passive House certification. In 2015, we did our first Passive House Institute certified project in the United States, or North America, actually. That was this project here in Queens. Then in 2022, we dramatically increased the number of products that were certified, and we added to it the hot climate certification. I believe we're still the only ERV manufacturer that has that. That's especially useful in North America. If you read the fine print in the PHI certification guide, you'll see that no matter what climate you're in, you should look at the hot climate data for the summer months. Like I said, it's fine print, but it is interesting because it does have some implications about how we help our customers select ERVs. In 2023, we introduced 3 versions of our small ERV. Small is PHI language for ERVs that deliver less than, I want to say, 600 cubic meters. And then coming soon, there will be a 4th and a 5th model of the smaller ERV. So in addition to just the HRVs and ERVs, we actually have a complete system that we feel is valuable to Passive House project teams. The HRV and ERV, of course, are kind of the flagship of all of that. They are all PHI certified. We use a rotary heat exchanger. A lot of other people use plates. There's some nice advantages of rotary heat exchangers. They're just as efficient as plates. Because of the control strategy that is used, because we use a rotor, we're able to operate with less frosting, and therefore we don't, in most climates, you have to get pretty far north in Canada, actually, or maybe Alaska, to get cold enough for us to require any sort of electric preheat during frosting. And that can save quite a bit of energy for those few hours a year when it's dramatically cold outside. The other thing we do with the rotary heat exchanger that you can't do with a plate is we can adjust the speed of the rotation to control the temperature and the humidity. And that allows us to use the rotor as the first stage of heating and cooling. So it's very accurate in that, and it really it changes the way we think about heating and cooling. And that is, we know that we get so much heating and cooling control out of the ERV that supplemental heating and cooling is really limited to those coldest or hottest days of the year. We also offer environmental product declarations on our products, which we've done for a number of years already, and we're continuously revising those as we make improvements to our product. We make all sorts of terminal devices, grills, registers, and diffusers. Transfer grill kits that are fairly unique in the North American marketplace. They're truly kits. They include a sleeve so that you don't get any air leaking into your wall cavity, but they're also fully supported with performance documentation, including sound ratings. I've been on some Passive House projects in North America, and the only thing you can't hear trains outside, you can't hear traffic nearby, but you can hear wind or air whistling through transfer grills and sometimes out of the supply grills. So it's important that products have these performance ratings. And then something we'll talk just a little bit more about later on is that we offer chill beam hydronic heating and cooling solutions. Passive House in North America has largely been a place where VRF systems have been widely applied. And with the recent and further upcoming refrigerant changes, VRF systems are getting increased scrutiny. And I think the value of the hydronic systems are getting new notice. We'll talk more about that. We also make volume and pressure dampers. That's not very exciting. It's a sleeve with a damper in it and some controls, but these allow us to control pressure in ductwork so that a lot of things happen. We don't have to, well, we are automatically addressing stack effect in taller buildings. We need pressure control to achieve demand controlled ventilation. So if you've got an apartment that's pretty far away from the air handling unit or the ERV, that unit doesn't get starved for air, nor does the apartment closest to the ERV get too much air. That's all accomplished with pressure control, and our dampers achieve that. Then for the individual apartments, we offer volume control dampers. So you can still have constant volume control in apartments or any occupied space, but you get extra comfort and extra energy savings when you use demand control ventilation. So as you might imagine, any of these topics I could go on for an hour, which I won't do here, but that's always an option if any of you and your teams are interested in learning more about these specific topics. We can support you there. Just last year, we introduced products that we've been manufacturing in Europe for decades, and that is air source heat pumps and chillers. The larger scale sorts, the kind that would do the heating and cooling for entire buildings, as shown diagrammatically here. Like I said, we've been making these products, even with today's R454B refrigerant, for about 15 years in Italy. As they started to phase out that product in Italy, we expressed interest to sell that product in North America. So we actually extended the life of a European product that was being phased out, which is kind of indicative of how far we are behind the European market. But that's the good news. In the future, we will bring to North America a propane refrigerant that will be compatible with the next level of refrigerant phase outs. So the bottom line is all of these things work together to achieve what we think is a pretty efficient and pretty low carbon, all electric Passive House solution. And I can't fail to point out that one thing that we offer that's also fairly unique is that all of these components are available with factory controls that don't require a building automation system. That's been pretty handy for smaller apartment buildings that don't have building automation system but want the benefits of robust controls. And that's something that Swegon's been known for a long, long time. So as you can see here, we've got quite a range of products that are applicable to the PHES certification. Airflow ranges from about 70 CFM up to around 6,500 CFM. Of course, you can use any combinations of these to achieve either more airflow, as we'll see, or maybe you need a big one and a small one, or you need a small one just in one part of the building. We can do all of those so that you get the comfort of knowing that everything's coming from the same manufacturer. Okay, any questions about that so far? What we're doing, what we offer? I see a hand. Well, if there is one, just feel free to shout it out.
How is
If you
your
go with,
price?
oh,
Sorry
sorry, go
about
ahead.
that. Hey, Mike, it's Doug Massey. And
Hi, Doug.
how is your price point for the very small units compared to the Dutch and the Germans?
Well, our product is actually Finnish. We build them in our factory in Finland and ship them over. We stock them in Toronto currently. We may stock them in Nashville soon. But our price point is similar to the rest of the market. One of the things that we don't do is we don't require any special accessories to use our equipment. And our equipment is routed through a slightly different distribution channel than other products, and that is our manufacturer's reps sell these products locally. So sometimes there's a benefit in doing that because they can package it with other equipment that might be on the project as well.
Okay, very good.
Yeah, thank you. So as far as reference projects go, you can go to the PHES database that's maintained by PHES Institute. You can search Swegon. You can see the 124 buildings around the world. I think it's 15 countries where our PHES solutions have been applied. We get a lot of experience by sharing information. So I've had the fun job of presenting to Irish architects and British architects and elsewhere. But our experience goes way back, and it's not just a couple of buildings. And as you may know, the PHES database doesn't have every project. It's always a challenge to get all of the certified projects into the database because it's not top of mind for everybody to do it. But you'll find us there. Some of our local reference projects, though, I can talk to you about. The biggest one, my favorite one to talk about because it was so much fun, was Sendero Verde in the Bronx. It now ranks as the largest PHES development in North America and largest PHES apartment complex in the world. Of course, that will always change. There's always bigger and better, but this particular project is PHES certified, has over 700 apartments. Since you all are in New York, you may have heard of this project or even heard the details of this project from the architect. What was fun about this project is we got involved with the architect before they hired an MEP consulting firm, and we were able to support their design team with information about our product for the pre-certification process. And that actually speaks to the way Swegon, the way we like to work with our customers. That is, although we have local representatives, we actually like to get involved directly and participate in projects as early as possible so that we can help customers gain the most benefit from proper application of our product. So this project, as we'll see here, this picture is one of 23 such ERVs on the project. They're all PHI certified. They are all around 86% in heat recovery efficiency. So you can see here that this particular project has lots of pipes sticking out of it, and that's because there is a heating cooling section there that's integrated with the VRF system in this building. So that is something that we work with the VRF manufacturers to accomplish. We're not linked to anyone in particular. We do not make our own VRF system, but we are happy to work with anybody else's VRF equipment. Even as we see more interest in hydronics, we still continue to support the VRF market. So that was a big passive house project. Here's a smaller one. This project had 24 apartments. This is actually one of our earlier projects. This goes back probably 6 or 7 years now. This is the Whistler Housing Authority's employee housing. So you can see it's a smaller project, different environment. In this case, we used one of our smaller Gold RX PHI certified ERVs. In this case, the way it's applied, it's about 84% efficient with a rotary heat exchanger. And that unit is in the attic space. You could actually mount these on the roof. There's not a problem with that. As you saw in the previous and the Sendero Verde project, that unit was outdoors. We actually have units that are outdoors and not covered with solar panels too, as you saw at Sendero Verde. This project also helps us talk a little bit about demand controlled ventilation. In North America, my observation is that most passive house projects so far are relying on constant air volume. And when I ask designers why that is, the answer is because we know it works, it's easy, we like to set it and leave it. I got to tour an occupied passive house project not too long ago. And the device that was doing the constant airflow control was making a lot of noise. So it's one of those things where you get what you pay for. It's true that a constant airflow damper costs less. I understand that, and they seem easy as a quick fix to get that issue of airflow control taken care of. But when you use something more like this is one of our react control dampers. It has its own controls. It's a product concept that's been on the market for decades, and it's able to give you extra energy savings. For instance, if you leave the apartment, you can have the occupancy sensor turn off the airflow or turn down the airflow to some minimum. And there is a lot of energy to be saved there, thanks to your giving the fans and the ERVs a break. So this small apartment building, 24 units, was able to take advantage of this using both react dampers and gold ERVs. The controls, I should mention I'll just say it again, that the controls in the air handler and the controls on the individual dampers are factory mounted. They're standardized. They don't require any programming. They do require setup, which is something our local reps assist with. But the setup is quite easy, doesn't require any tools. They both are adjustable using your bare hands. Here's another new project. This was one of the tour destinations for Passive House Canada earlier this summer, and it's called La Pêche. La Pêche is a town in Quebec, north of Ottawa, Ontario, and they built themselves a new town hall. They're in the process of gaining Passive House certification, and it's the first project in North America that did not use a VRF system that I'm familiar with, but in place of that is using a hydronic system for heating and cooling in the space. So it's unique in that it's not an apartment building. So many passive house projects have been apartment buildings. It's one of those things you have to wonder, why is that? It's easy because we've got so much experience doing passive house apartments. But the greater opportunity is for all building types to become passive house certified. So as we know, if we're tapped into PHI at all, we know that there are passive house grocery stores, hotels, even a hospital. So it's pretty exciting for us to see that the application of our product is expanding beyond just residential and into something like a government office building. So here's one of our Gold RX units. I think it's a little hard to pick it out here, but right here is a four-way blow chill beam being used to provide heating and cooling in this office. So if you're not familiar with chill beams, they simply use hot and cold water to change the temperature of recirculated air, and the air is recirculated without a fan. So if you're familiar with a fan coil unit, you have a fan in the occupied space that sucks air out of the space over a coil and then recirculates it back into the space. A chill beam replaces the fan with induction, and induction works by using duct pressure that's created by the ERV fan. That duct pressure sucks air over the coil and then mixes it back into the space. So if you've ever cracked open your car window when you're driving down the freeway, my grandfather gave me my earliest example of induction. He used to smoke, and I'd be riding next to him, and when he smoked, he'd crack the window open an inch or so, and the smoke, most of the smoke from his cigarette would get sucked out the window. That's what's happening with induction. It's the induction concept was actually patented by Willis Carrier, the founder of Carrier, back in the 1930s. And the first installation goes back to before World War II. Products have been on the market since then. So nearly 100 years of use of induction technology. And so we're happy to see that this project is also benefiting from not having refrigerants in the occupied space, because the heating and cooling is being moved around the building through water. So all of those complications of refrigerant monitoring, refrigerant emissions go away when you use a chill beam instead of a PRS system. Okay. Again, this building doesn't have a building automation system. And in its place, they're using our factory installed controls. I think I talked about all of these things already. A few weeks ago, I finally got to go visit Hotel Marcel in New Haven. You can see a glamorous photo of this project in the background. Maybe you've seen this one. This must be the most publicized PHES project in all of North America. If you go to the Hotel Marcel website, you can see their press list. It's very well documented. There's some really good information there. You know, if you're interested in solar, you can dive down and talk about solar on hotels and things like that. This project it's a brutalist building, so it's a very massive concrete building, which lended itself pretty nicely to passive house, I believe. It's 165 rooms converted from commercial office space that had been abandoned several years before. So Bruce Becker, who is a lifelong architect, is also now a developer, and he continues to own this hotel. So he's very passionate about the Passive House concept, and he has retrofit this building to become not only Passive House certified, but it's actually net zero. So our Gold RX ERVs were chosen to ventilate this space as well. It's an inspiring project for those that are considering retrofit. And of course, that's where the real energy and carbon is to be saved, is by retrofitting older buildings with newer technologies. And I think Bruce went a long way in proving that it's possible. Okay, so that's what I had for today. If there's any more questions, be happy to take them. If not, or while you're thinking of questions, I'll just emphasize that if you follow this link, that should take you to my LinkedIn page. You can contact me anytime if you're working on a project, and we'll be happy to support you. We do lots of product selections to help customers figure out how big a unit would be for their upcoming Passive House project. right up through the submittal phase, making selections, helping customers pick the product in a way that meets PASPAS requirements. It's not an automatic thing. It has to be done consciously. And then, of course, I already mentioned we do webinars. There will be, we'll be doing a full ventilation, PASPAS ventilation webinar in October. And we are always offering as well lunch and learns for clients and project teams. Looks like there's a question upon.
Yeah, I'd like to know the, you mentioned 600, was it square foot or square meters? And that was sort of, yeah, I didn't understand.
Oh, I'm sorry, 600, I want to say cubic meters per hour.
Okay.
Airflow rate. So it works out to around 200 CFM. So for some reason, PHI chose to have two different categories of ERV, energy recovery ventilator. They call them small and big.
Right.
I'm not quite sure of the need to do that, other than maybe breaking the program in two so that the two sets of data were smaller. But in reality, I think it's a mistake to call a small ERV a residential ERV, because we know that on projects, big projects, it's often seen that there will be a combination of small, it's our model CASA. So small CASA units might be on the same project as big gold RX units. Right. So it's not really a residential versus non-residential, it's just a size thing.
Thank you.
Any more questions?
Actually, one more.
Yeah, go ahead.
Are you considering ever having a building these units in the United States?
Yes, we are, for a number of reasons. One is, of course, we like to make product close to our customer. So yes, I can't give you too many more details than that, but that is on our long-term horizon. It does, since you asked, I'll use it as an opportunity to share with you something we learned when we developed environmental product declarations. That is, for years and years, USGBC through LEED has encouraged building project teams to source their material from the closest possible factory. Sounded like the right thing to do. But in reality, first of all, when it comes to HVAC equipment, if you're in certain parts of North America, there is not a manufacturer that's very close to begin with. It's not like lumber, where you can get your lumber from, you can use local lumber. But what we learned when we were doing EPDs is that approximately 99% of our carbon footprint has to do with our suppliers. And not only where they're located, but the quality of their material. So that was two things. It was an eye opener. First of all, it gave us this new awareness of, okay, where are we adding carbon to the environment? So you can see on our website lots of case studies and discussion about how we recently changed to this material called Magnellus for the inside of our gold units. Magnellus is recycled steel that's resmelted in electric arc furnaces, so that we were able to reduce the carbon footprint of our air handler by about, I think it's 15% so far, and there's more to come because we're going to also do the external casing. But what we learned from that is we could use that material in a North American factory, and we would have essentially the same overall life cycle analysis of our product. It was quite surprising. But then we started to realize too that when you ship your product from afar on a boat, ships have a pretty low, I think they're still the lowest means of transportation and in terms of carbon output. So there's other reasons to build in North America, and it's those reasons that are driving us, but it's the big picture that we're really interested in. So that was a very long-winded answer to your question. Any other questions?
Mike,
There
Yeah.
are some there are some questions in the chat.
Oh, okay. Let me get in there. I had it open
Actually-
earlier.
I actually put one in the chat, so I'll jump in.
Yes, please.
Do you make, somebody else actually asked this question, are there single family residential systems that Swegon does, or is it just commercial and multifamily?
Yeah, so the answer is yes. We have two models. CASA is the model that was on the first slide here. I'll scroll back up. With a PASFAS certified ERV, we can deliver as little as 70 CFM, which is about what you would need for a small apartment. So there we go. So you can see down here, I should have put the scale. It's 0 to 7,000 CFM, cubic feet per minute of air. So our smaller units are called CASA. That's their model name. And the larger units are called Gold. That's the model name.
Okay.
And then, of course, some of the other accessories that I described, grills, registers, diffusers, transfer grills, React, those could all be used in residential as well.
And my second question was, do you make any kind of componentry for domestic hot water?
Today, our domestic hot water solution is to use a heat exchanger in connection with our heat pumps. So we do and we don't. Do we have a domestic hot water heater? No. We might in the future, but we don't today. So if you use a multifunction, let's say you've got an apartment building with a multifunction heat pump that's simultaneously delivering cooling and heating, it's pretty easy to use that heat pump as your domestic hot water source. And we have all the wiring diagrams and application notes to do that. So the answer is yes.
Great. Thank you.
All right, I'm scrolling through the other questions here. I don't see any more. So I guess I'll turn it back over to Susie, but not before saying goodbye. Thank you for having me in today, and I'll encourage you to contact me.
Sorry if I could jump in.
Yes.
There was one more question.
Oh, I
Are
missed it,
there,
sorry.
and do you guys produce, do you guys produce induction units integrated with the ERV for single family residential?
Oh, by integrated, the answer, okay, I'll say yes and I'll qualify it. There's not a single piece of equipment that would do that. However, you can use the small ERVs, the CASA model, for instance. They have enough pressure to drive induction units. And we actually have a special induction unit that we have configured for apartments. It's called the CASA Climate Solution. So it's something we'll be rolling out in North America soon. We don't have a date on that, but it's a spin-off of this modular concept we have, where mechanical block in the middle of an apartment can contain not only the shower and the toilet, but also the mechanical equipment, including the induction unit for heating and cooling. And then you'd have a single heat pump chiller in a mechanical room or on the roof. And through that, we realized we could do better taking our commercial induction unit and making it more residential. So again, the answer is yes. And it's something we can help you apply.
I really like the idea of integrating the ductwork of the ERV for the HVAC.
Yes, and I'm kind of reading between the lines there. I've observed that there has been a little confusion, and actually sometimes I've seen it promoted that the ventilation is always, without question, separate from the heating and cooling. And We don't really subscribe to that idea. You can do it that way successfully. Don't get me wrong. That's proven. It can be that separated, but I believe, and we believe, that opportunities are missed if you don't take advantage of your ERV to do your first stage of cooling. We spend hours and hours designing buildings based on the worst day of the year for heating and cooling, and then we ignore the other, the worst conditions. The 0.4% of the time accounts for about 2 weeks of the year at the most. The rest of the time is when you have lots of opportunities for energy savings and enhanced comfort. And that's why we think it does make sense to integrate all of these things together. Use your ventilation air for cooling, and then add to it some induction cooling if you need it, but only when you need it. And that's a good strategy, and that's been a proven good strategy as well.
Thank you.
And I lost power for a moment, so I apologize. If there are other questions in the chat that I missed, I don't see them right now, so just chime in. I have a question. What would you recommend for ADUs? This comes up all the time in Los Angeles right now, especially, but California, of course, is really pushing extra housing where we can fit it in, and folks are concerned that passive house isn't possible because not just the insulation issue, but really the ERV issue.
I find it hard to imagine a scenario where you couldn't use one ERV in any size building. I mean, we've made air handlers out of shipping containers.
Yeah, that's what I'm thinking specifically. Yeah.
And our ERVs, the small CASA units are small anyway. I mean, if you've got space for water heaters, actually our concept is that your ERV should probably fit like above your washer dryer. It should be about that size. Or maybe in Europe, we put them above the stove quite a bit. It's a convenient place to put it. You're allowed to do some things in Europe that we're not allowed to do here, like use your ERV for kitchen exhaust, for instance. So, but there's no reason you can't use a small ERV in any size dwelling.